Okay. In your book, the last part of this section has to do with acids, of which there are two different types of acids. Okay. And acids are going to contain a hydrogen ion bonded to an anion. And here, acids are going to be special types of molecular compounds that will form ions when we dissolve them in water. And the names are really based upon whether they contain oxygen or not. So what I'm going to do is, let's go to the next page. Let's see what's on this next page. Let's come down here. And I'm going to give you some notes underneath these practice problems that we'll use. And then I'll also be taking a look at some things that are on the nomenclature periodic table that you have, because I gave you a little cheat sheet for naming acids, okay? So, two types of acids. The first type are known as binary acids. Binary means two. The two things that binary acids contain are hydrogen and some other nonmetal. And these have to be dissolved in water. So when we name them, we put hydro in front, ic on the end, and then we write acid. There aren't a ton of binary acids. To give you an example of a few, here are three different ones. Notice they contain hydrogen attached to a nonmetal and they're dissolved in water as indicated by the AQ on the end, okay? Your textbook tends to not put an AQ on the end, but in reality, if the AQ is not there, you would name that compound something completely different, okay? So here what we're going to do is practice naming them. We're going to start with hydro, and then we're going to change the ending of the nonmetal that's attached to hydrogen to ic. So this one here would be hydrochloric acid. So I put hydro in front of chlorine. I change the ending of chlorine to ic. For the next one, this would be hydronitric acid. For the last one, this would be hydro. Why isn't it letting me write? Maybe because I'm so far down on the screen. This would be hydrosulfuric acid. Okay. If you're going in the opposite direction and you're writing the chemical formula, we will still look at the charges that are on the periodic table. For instance, this hydrochloric acid is from a hydrogen and a chlorine coming together. Obviously, I would need one of each. That's how they get the HCl. If you don't put the AQ on the end of this, technically this is hydrogen chloride. With the AQ on the end, it's an acid. That's hydrochloric acid. Hydronitric acid comes from hydrogen. Nitrogen has a -3 charge on the periodic table. So this shows you that you need 3 hydrogens in the formula to make it neutral. So H3N would be the appropriate formula. If you don't put the AQ, this is hydrogen nitride. With the AQ, it's an acid. That's hydronitric acid. You get the idea? Okay. Now, for the other type of acids, oxyacids, there's a totally different naming system. I don't know if you want to look at your nomenclature periodic table and you want to maybe like highlight the binary acid information that's on there just so you don't forget that I gave it to you. It's on the bottom right under acids. It says begin with H, and then you see the hydroic, no oxygen. So they often refer to these binary acids as acids that do not contain oxygen, okay? So this is the only time you will ever put hydro in front of a name. Okay, don't mess that up and then start putting hydro or hydrogen on everything, because a lot of students start doing that. They just kind of forget because there's so many rules. But this is the only place where you'll ever have hydro at the very beginning, okay? Okay, now the second type of acids, which are oxyacids. Can I erase this and write the oxyacid notes down here? You guys have this? Okay, so for oxyacids, and these notes are also in the chapter review packet. Oxyacids contain oxygen, so this will be hydrogen, followed by a polyatomic ion containing oxygen. And when you write these chemical formulas, the AQ is not required, okay? If you put it on there, great, no big deal, it's fine. So let me give you an example. If I give you HNO3 versus HNO2, anytime we're naming oxyacids, you have to determine what the name is of the anion first before you can actually figure out what the name of the acid would be. And the reason is because ATE ending polyatomic ions will change to ic acid. ITE ending polyatomic ions will change to OUS acid. Okay, so NO3 on your periodic table, this is called nitrate. So that means you will change the ate to ic, and this would be called nitric acid. For HNO2, NO2 is called nitrite. Ite becomes OUS. So this is called nitrous acid. Okay? If you guys were going in the other direction, we are still looking at the ions to determine the formulas. So what I mean by that is, if you're given something like chloric acid or carbonous acid as examples, ic acid means you really have an 8 polyatomic ion attached to hydrogen. So this would be hydrogen with chlorate. Chlorate on your table is ClO3 negative 1. So since you have a +1 and a -1, you would need one of each, and this would become HClO3, okay? For carbonous acid, the OUS acid came from an ite ending polyatomic ion. That means you have a hydrogen with a carbonite. Carbonite on your periodic table is CO2 negative 2. So this means you need 2 hydrogens and 1 carbonite. So this formula would be H2CO2. And like I said, the AQ is optional. If you put it on there, it's fine. It's not incorrect. You just don't have to do it, okay? So do you want me to do a few more practice problems with you here in your book? Okay. So these practice problems are a mix. So if you take a look at number 1, A has got hydro and D has got hydro. So that means A is a binary acid and so is D. And that should help us with writing their formulas because binary acids are only made of hydrogen and then some other nonmetal. So this would be hydrogen with fluorine. So that means we would have HF. And the AQ is required. So I have to include it. For D, hydrosulfuric acid, this would be hydrogen and a sulfur. I would need 2 hydrogens to make it balanced and have the charges add up to 0. And then you have to put an AQ on the end. Okay. For number 2, I'm just going to jump down to letter D. I realize they did not include the AQ. Technically, it should be there. This is a binary acid as well. And then when you name it, you put hydro in front, ic on the end. So this would be hydroiodic acid. Okay, that sounds better than hydroiodinic. So chemistry teachers will always tell you, go with the one that sounds better. Okay? All right, now, the rest of these are oxy acids. So this one, this one, this one, this one, and this one. I'm just making a little note here that these are oxy acids. Okay, this is where we have the ate and the ite endings that become ic and ous. So let's use a different color here. This is ous. Ous means I had ite. So hypochlorite is attached to hydrogen here. Okay, so this would be an H plus 1 and a ClO minus 1. So HClO is the hypochlorous acid. Okay. Over here, phosphoric, ic, means I had an 8. So that means I've got hydrogen attached to phosphate. So H plus 1 and PO4 negative 3. I need 3 hydrogens, so H3PO4 would be phosphoric acid. And then for A, you have to be kind of careful here. This is a weird looking one. This is the one that you guys wrote on the bottom left of your periodic table. So when you're naming oxy acids, you want to identify the anion, which is the second ion in the formula. This is acetate. Since it ends in ate becomes ic. So this would be called acetic acid. Acetic acid is in vinegar. Okay. For B, SO3 is sulfite. Ites become OUS. So this would be sulfurous acid because it sounds better than sulfus acid. Okay? And then the last one, CO3, this is carbonate. 8 endings become ic. So this is carbonic acid. This is in Pop Rocks. Decomposes to water and carbon dioxide in your mouth and you eat Pop Rocks. Okay? Okay. On your periodic table on the bottom right, the little like cheat sheet for oxy acids is down there with the ic acid and the OUS acid. I'm sure you can see it. I don't know if you want to highlight that in a different color just so you remember that it goes with the oxy acids. It's your call. But now you probably could use additional practice. You've got it. You've got the binary acids, and then you've got a whole mix with the key. And then the last page of that packet is nomenclature practice. So this is just like a mix of everything, and then there's a key that goes with it. Okay? Okay. On